In this lesson, we're looking at advanced factorization and expansion. Now, the real secret factorization and expansion is familiarity. So if you know your patterns and you're comfortable with the processes, then generally this is pretty straightforward. And the better you build up that fluency, the more prepared you're going to be looking at complex scenarios in senior mathematics. To go along with this lesson, there is a consolidation lesson. So if you find that you're not following when we're looking at special expansion, factorization templates, binomial expansion, and basic factorization processes, then I'll put another lesson in when we're looking at these quadratic processes and linear processes. Now, if you're finding any of these things difficult, including completing the square, then you can go to this secondary lesson and you can use that to brush up on some of the skills, and also a set of exercises or questions that you can utilize to build fluency and get to a point where you can jump from that into this higher level factorization and expansion. Okay, so the focus obviously is we'll start by looking at some of the special expansion factorization templates. Some of these you will know, some of them will be new. So obvious one that we generally need to be able to work with is DOPS, so difference of perfect squares. I don't care if you know what the name is, but I do care that if you see a pattern where you have a product of a sum and a difference, that you recognize that pattern can be expanded into the form a squared take b squared. All right, obviously the positive AB and the negative AB cancel out when you go through that expansion. The second pattern that you need to know is perfect square pattern. So in this one, you've got a plus b squared, which we kind of know is a plus b squared, which is a plus b multiplied by a plus b. So it's a product of that same bracket. And when we expand that out, we get a squared plus 2ab plus b squared. So this is a pattern that you should know and remember and be able to utilize to expand. We also have a square difference, so a subtract b all squared will expand to a squared take 2ab plus b squared. Now the ones that you don't know that I probably would like you to know in the long run is difference of cubes, so DOCS, and that will be a subtract b multiplied by a squared plus ab plus b squared. So that will expand to a cubed take b cubed. Now it won't pop up very often, but it will pop up. It'll turn out in different exercises, and if you know it, will make your life a lot easier. And the sum of cubes will be a plus b, and then a squared take ab plus b squared. Now, if you're not sure about any of these, you can take any of them and go through that expansion yourself and just prove to yourself that this is a true representation. Now, it's also pretty important to understand that these work both ways. So we can take a factorized form and we should be able to jump straight into the expanded form. So we should be able to go from our factorized form to expanded form. And just as important is that we should be able to recognize the expanded pattern and be able to turn that back into a factorized form. Now, if you were to go down that path where you wanted to test that each of these work, you can pick one and you can go through that expansion and show yourself that it is a true representation. So let's take DOCS, for example. A take b multiplied by a squared plus ab plus b squared. And we'll expand this out. Remember, with expansion, the whole idea is that each value in each bracket is multiplied by every value in the other bracket. So if I'm going to expand this out, my first three expansions will be multiplying a by every value in the other bracket. So we have a cubed plus a squared b plus a b squared. And now we're going to multiply this negative b, multiplying negative b by each of these three values. And from that we get negative b a squared, negative a b squared, and negative b cubed. Now we should be able to see here that this a squared b and negative ba squared are the same, so they cancel. And this ab squared and negative ab squared are the same, so they cancel, and we end up with an a cubed take b cubed. So that allows us just to confirm that relationship and being able to use that then for expansions. Right, a real quick example. So if I was to use this, a real quick example, just to show that if I was to try and use this, it can be quite beneficial. So if I'm looking at x plus 3 squared, or x plus 3 all squared, I can straight away say that that's going to be x squared 2 times a times b, so it's 2 times 3 times x, that gives us 6x, and then plus b squared is 9. Now we want to be able to do it in that single line. Exactly the same if we have something like 2x plus 5, 2x take 5. Straight away we can see that's a difference of perfect squares, and we're looking at 2x all squared, which is 4x squared, and 5 squared, which is negative 25. So any of these patterns should allow us to take a shortcut in a single line, and usually it's just a small part of a bigger process. Alternatively, if we see these patterns, so this is our expansion, our factorization should be just as simple. So if we had something like a x squared take 9, then we should be able to see that that's an x squared take 3 squared. And because we can see that pattern, we know it's a difference of perfect squares, and we can say it's x plus 3, x take 3. Alternatively, we might be able to see a perfect square scenario, so it might be that we're looking at x squared takes 6x plus 9. Now we can see that there's that relationship between the 6 and the 9, so we've got 3 squared, and this is 2 times 3. If we can see that relationship, then we know it's going to be a perfect square. In this case, because of the subtraction, it's going to be x take 3 squared. Okay, so you'll all be at different places with this skill. Some of you will see it and be able to do it immediately. Some of you will take some extra practice to get up to a point where you can recognize it and be able to work confidently with it. So we'll push forward and we'll look at binomial expansion. Binomial expansion should be something you're pretty familiar with from year 9. So it's that scenario where we're looking at a product of 2 brackets with 2 values within, so a plus b multiplied by c plus d. Our process should just be that we're multiplying each value in each bracket with each value in the other bracket. So we're looking at multiplying a by c and d, but also b by c and d. So that will just be a simple ac plus ad and bc plus bd. Now, if we extend on this a little bit, it doesn't matter how many elements we have in each of those brackets, the idea is the same. So if we have an a plus b plus c multiplied by d plus e plus f, then it should just be that a is multiplied by each of those values. So we've got an AD plus AE plus AF, also that B is multiplied by each of those values, and that gives us a BD plus BE plus BF, and also that C is multiplied by each of those values, and that gives us a CD plus CE plus CF. Now, most of the time, we won't be horrible and make you do things like that, but it's good to understand that process. Now, if we step forward just a little bit and we look at multiple expansions, the whole idea with multiple expansions is that we maintain our understanding of multiple multiplications, in that if we have a 2 by 3 by 4, the idea is that we can do them 2 at a time. So we start with 2 by 3 and we get 6, and then 6 by 4 will give us 24. So with multiple expansions, we're looking at only completing a pair of expansions at a time. Now, if you're intelligent, you're able to work out which are the easiest ones to do through each step to reduce the complexity of the calculations that you'll have to perform. So let's look at something like this. We might say x multiplied by x plus 1, x plus 2. Now, I would say that this expansion is probably the easiest to perform first. So we keep our x there, and we look at the expansion of x plus 1 multiplied by x plus 2. Now, we expand that, and we get our x squared and 2x and x plus 2, and that means we're looking at x multiplied by x squared plus 3x plus 2. And now that we've completed our first step, now we can expand again. So we can multiply x by each value within the bracket, and therefore we end up with x cubed, 3x squared, and 2x. So there's our full expansion. With multiple expansions, that's the only idea you have to maintain. Obviously, all our prior skills are still relevant, but if we complete 2 expansions at a time, we should be able to get to a point where we've got a logical and complete solution. Now, factorization is another kettle of fish. I imagine in terms of skills, you're a little bit less developed with factorization than you are with expansion. The idea with factorization, obviously, is that you're reversing that expansion. You're taking out any common factors. So if we have an AB plus AC, the idea is that if we take a common factor A in front of a bracket, then technically what we're saying is that we're multiplying all the elements within that bracket by A. So in order to do that, we'll have to divide every element by A. So we bring A out as a common factor, and we're left with B and C when we divide each of these two terms by A. With factorization, obviously, there's a whole lot of different skills. So I'll write them over here to the side, and the idea is we've got all these different things we can do. So the first thing, obviously, is common factors. We also know that there's those special patterns that we just talked about, and so that might be dots and perfect squares and socks and docs, and you might know of more also that allow you to shortcut processes. We also know that we've got factorizing by completing the square, and we also know that we've got using decomposition. So if you don't remember with those quadratics, it's at A, C, and B. And some of you will also know about factor remainder theorem, and there's lots of other processes as well that go along with factorization. Now, the idea here, what I want to talk about, is that when we're looking at factorizations, we want to make sure we consider an order. So the first thing that we'll always do, the first step will always be check for common factors. So if you can see any common factors, then make sure that you factorize them out. The second thing is that you'll check for patterns, particularly those special patterns that we know. If you can see special patterns and you want to factorize them out as well. The third step is that we can look for decomposition, so that quadratic factorization. Fourth step is that we can try completing the square. Again, it needs to be a quadratic if we're going down this path. And then finally, if none of that works, then we can look at applying that factor remainder theorem and polynomial division. Now, the big thing for you is mostly going to be these first couple of steps, making sure you first look for common factors and then you check for any special patterns. If you can do that, then that'll get you through the majority of the questions that you can be asked. This leads us to multiple factorizations. Now, multiple factorizations happen when you've got something like common factors and then some other pattern. So one factorization at a time. Now, I just might really quickly do one of these, and it might be something as simple as we're trying to factorize 2x cubed minus 18x. So I made this one fairly straightforward. Hopefully you can see straight away that there's a couple of common factors there. So we can see that 2 is a common factor, but also x. And as soon as we pull that common factor out, we're left with x squared and 9. So this is what I mean by being able to, first of all, pull out common factors, but then see any patterns. So this guy here, you should notice straight away, is DOPS. And it's in that form, x squared take 3 squared. So we can then complete this factorization. We can say this is 2x, and this x squared take 9 can be factorized into x plus 3, x take 3. All right. So they're the skills that I wanted to go through. Now we're going to look at a couple of examples, and once we've done these examples, you can put them to practice in either a simple set or a more complex set. All right, so we'll start with some expansion. Expand 2x squared multiplied by 3x takes 7. So the idea is we're just multiplying each of these values within the bracket by that 2x squared. So that gives us a 6x cubed, and 2x squared by negative 7 is negative 14x squared. So as simple as that. Now it should only take you one line to do that. When we pop forward to the next one, first of all, 2x squared is multiplied by each of these two values. So we've got 10x cubed, and 2x by negative 7x is negative 14x squared. Then you've got 3 by 5x squared, which is plus 15x squared. And then 3 by negative 7 is negative 21x. So we should be able to see that these two terms here are like terms. And so we can combine them, and we're left with 10x cubed plus x squared take 21x. Okay, so nice and straightforward as long as we follow our processes and we're careful with our index laws and making sure those powers are correct. Next one's a little bit more complex. We've got a scenario where we have to do multiple expansions. So I'm going to focus on the brackets first. So that means our answer will be 5y multiplied. Now, expanding these brackets, we've got 2y by each of those three values. So that gives us 4y squared, 2y cubed, and take 4y. And then we multiply negative 3 by each of these values. And we've got negative 6y, negative 3y squared, and plus 6 because negative by negative. So we've got 5y, and if we simplify this, we've got 4y squared take 3y squared, which gives us y squared, plus 2y cubed, negative 10y, and plus 6. Now we can multiply each of these values by 5y. So we've got 5y cubed plus 10y to the power of 4, take 50y squared, and plus 30y. It's a little bit long-winded, and you have to be careful, but hopefully that's a process that you can build up to. So a couple more expansions here, and here we've got 5 multiplied by what hopefully you can see is a DOPS scenario. So if we can see that pattern, we know that the easiest thing to do is to expand that first. So 2x plus 5, 2x take 5 gives us 4x squared take 25. So square take a square. When we multiply by 5, we've got 20x squared take 125. So that's a real quick expansion if we know our special patterns. Now later on you'll find out that there is a pattern here and that you can shortcut it, but I'm not going to do that today. So we're going to expand this by breaking it into 3x take 4 multiplied by 3x take 4 squared. Now this is a perfect square, and we should be nice and quick with this, remembering that that pattern is going to be the first thing squared. So we've got 9x squared, 2 times a times b, so 2 times 3x, which is 6x, multiplied by negative 4 is negative 24x, and then negative 4 squared is plus 16. Now we've got that, we can go through our expansion, first of all multiplying them all by 3x. So that gives us 27x cubed, negative 72x squared, plus 48x. And now we can multiply them all by negative 4. So that's negative 36x squared, plus 96x. And then subtract 64. Now when we simplify all of this and we put it back together, we've got 27x cubed, negative 110x squared, plus 144x, subtract 64. Okay, painful but manageable. So now we'll go through a few factorizations. Most of these are on the complex side, so if you need practice with the simple stuff, you can go back through to the secondary lesson. So you can see we've got a few questions here. All right, so I'll work through these pretty quick. First thing here is we should recognize a common factor. So we've got x squared plus 6x plus 9. Now this, hopefully, you recognize as a perfect square. If you don't, you can go a, c, and b, and we've got 9 and 6. That gives us 3 times 3 and 3 plus 3. And we can see here that's a monic quadratic. Both of the values are 3. So we've got x x plus 3, x plus 3, or a better way to write it is x plus 3 squared. So nice and simple. The next one is again having to recognize that it's a quadratic, but it's in terms of x squared and y squared. So if we think of this as x squared squared, take 2x squared y squared, and y squared squared, then hopefully you can see this as an a, c, and b scenario. So a times c is 1, b is negative 2, and so therefore it's negative 1 by negative 1, negative 1 plus negative 1, so it's another perfect square. And of course our values are x squared and y squared. Then we've got x squared take y squared, and x squared take y squared again. So we're left with x squared take y squared squared. So if you go right back up to the start, you should be able to see that that's that perfect square scenario, almost at a squared plus 2ab plus b squared. Next one is recognizing that square take a square scenario and being able to manipulate. So we should be able to say that this 36x squared is actually 6x all squared, and this 9y squared is actually 3y all squared. As soon as we can do that, the factorization is easy because it's a square take a square. So it's adopts, and we've got 6x plus 3y and 6x take 3y. When we take the next step, again, it's about recognizing that adopts. So this next example, we've got a square take a square again. So that means in our brackets, our first one will be the sum of these two. So 5x take 2 plus 2x take 3. And we'll be multiplying then by the difference of those. So we've got 5x take 2 subtract 2x take 3. Make sure you're subtracting that whole bracket. So that gives us 7x take 5. And this gives us 3x and take 2 plus 3. So that gives us plus 1. Okay, so now that's fully factorized. We can also look at quadratics where one of those components is a bracket. So we're looking at decomposition. Hopefully you can see this as a quadratic. We've got something squared plus 10 times something plus 24. Some people like to do something like this. So go let x equal, so we call this super x equal x take 5. And that makes it easier for them to see that this is a quadratic. So we can say, well, that's actually super x squared plus 10 super x plus 24. Now, when we do that, the quadratic's easy to see, obviously. Super x has come to the rescue, and we've got 24 as AC, and B is 10. So now we've got that. It's just a matter of realizing that that is 6 times 4 and 6 plus 4. And this is a monic quadratic, so we can jump straight into x plus 6, x plus 4 as our factorization. Now it's not complete because we want to do it in terms of normal x, not super x. So we can replace super x with x take 5 and x take 5. And we're left with x plus 1, x take 1. So it's a little bit mean in the sense that it ends up just being worth a perfect square. One other thing you could do if you wanted to is you could expand this out at the start, and you would have recognized when you simplified it down that it was just going to be a square take a square. Okay, hopefully that makes sense. So there's another skill, using super x to replace something to make it an easy factorization. All right, last one. This one's a bit of fun. Now the real secret is if you can look at this and recognize that pattern. Now if you look at it carefully, you should see that that's actually our perfect square pattern, in that a take b all squared is a squared take 2ab plus b squared. Now if you can see that, then you're sitting pretty, because this is a couple of lines to be able to do this factorization. So if we can see that pattern, we know that this is actually just a p take q all squared. And so once we've done that, we've still got our negative r squared, but this becomes a familiar thing. We've got a square take a square. And as soon as we've got a square take a square, we recognize that we're dealing with DOPS. and that means we're looking at a sum and a difference. So the sum being P take Q plus R, and the difference being that we've got P take Q take R. All right, so we can't factorize that anymore. Fully factorized, and we're all very happy. Right, so that concludes my examples. Obviously, there's some pretty complex factorization and expansion in here. So it comes down to you being able to do the precursor skills so that you can engage in those multiple factorizations and those multiple expansions. All right, set of exercise is attached. You get some nice expansions, some nice factorizations. Gets down to some pretty cool stuff at the end, which will definitely challenge you in to be able to get the right fully factorized simplified answer. Okay, thank you for listening.